1.7 Exponent laws. This lesson is about discovering rules for simplifying expressions involving powers. Okay, so let's look at what is a power? Well, a power looks something like this. It's going to have a base, so it's a number. Okay, let's say it's 2. And it's going to have an exponent. And let's say this exponent is a 4. So the 2 here is the base, and the exponent is 4. And the entire term that you see here is called a power. And sometimes in everyday language, we say 2 to the power of 4. And that's perfectly acceptable. But in mathematics, we refer to the whole thing as a power. We have a base raised to an exponent 4. Okay, that's how I'm going to read that. So let's complete the table that we have here. Let's look at trying to come up with some rules. And so if I have a base, the base is 3. If I write this as a power, well, I can choose an exponent of 5, 3 to the power of 5. And what does this 3 to the power of 5 mean? It means I'm just going to take the number 3 and multiply it and write this 3 out 5 times. So 3 times 3 times 3 times 3 times 3. Okay, so there are 5 3's here being multiplied. And when you evaluate these 5 3's and I multiply all of them together, I get 243. Okay. So now here, power form, -4 in brackets, raise the exponent 3. My base here is -4. You have to include the negative because it's part of the bracket. In expanded form, I'm going to write -4 3 times, so -4 times -4 times -4. And when I multiply these 3 numbers, keep in mind your rules for negative signs. So I have 1, 2, 3. I have an odd number of negative signs, so that my result is going to be negative. And so 4 times 4 is 16. 16 times 4 is 64. So there's my evaluated form. -7 squared. So now keep in mind the negative is not in the bracket. There's no bracket. So the base is just 7. So I'm going to just put a note here. No bracket. And so that's why we're going to say the base is 7. And in expanded form, I'm going to say 7 times 7. And remember, the negative is outside. And 7 times 7 is 49. And the negative is outside, so it becomes -49. Okay? Then, next one. If our base is -2, and we want to evaluate this so that we get 16, it just turns out that, well, okay, so 2 times 2, so -2 times -2 times -2 times -2 will give me positive 16. So 4 negatives is an even number of negatives, which means my answer is positive. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And how many 2's are here? So you have 4. So if I want to write this as in a power form, I'm going to write here my base, -2 in brackets. I'm going to write my exponent 4. Okay, 5 over 6 to the power of 3. Well, that is the same thing as saying 5 over 6 times 5 over 6 times 5 over 6. And this is a power with a base of 5 over 6. You can have a fraction as a base as well. Multiply all the numbers in the top to evaluate this. So 5 times 5 is 25, times 5 again is 125. And on the bottom, I have 6 times 6, which is 36, times 6 is 216. Okay, so, well, what does this lead us to have? So let's just try and look at something called a multiplication exponent law. So this is a new law. I'm going to teach you how to evaluate exponents without doing all these expanded forms all the time. But to get to that law, I'm going to just show you what expanded form would look like here. So if I have 5 to the power of 4 times 5 to the power of 5, all I'm doing is 5 times 5 times 5 times 5, which is that is the 5 to the power of 4. And then I do have 5. So again, 5 more 5. So 1, 2, 3, 4, 5. How many 5's do I have in total? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the same thing as saying 5 to the power of 9. Okay. And next one. So if I have 2 to the power of 3, and 3 to the power of 5, and 2 to the power of 2, and 3 to the power of 3, I can expand this by saying, well, let's take care of the first one. So 2 times 2 times 2. So that is the 2 to the power of 3. 3 to the power of 5 would be times 3 times 3 times 3 times 3 times 3. So there's 5 3's here. to the power of 2 again, so times 2 times 2, and 3 threes this time, so times 3 times 3 times 3. Wow, a lot of 2s and 3s. But how many 2s do I have in total? So I have 1, 2, 3, and over here I have 1, 2, so I have 5. I can write this as 2 to the power of 5. Put some brackets around that because there's another number here. So 1, 2, 3, 4, 5, 6, 7, 8. I have 8 3s, so I can multiply that by 3 to the power of 8. So notice you keep the bases separate. We're not going to combine them as another power. Okay, but I did simplify. I went from two powers with 2 as the base down to 1. I went with 2 powers with 3 in the base down to 1 power with 3 in the base. Okay, and then 2 over 3 squared times 2 over 3 cubed. So here I have 2 over 3 times 2 over 3. That's the first term. Then I have to do 3 more. So 1 and 2 and 3. Okay, so if I multiply all of these fractions together, I could get an evaluated answer, but I want to just simplify this just down to a single power. So I'm going to go from 2 powers down to a single power over here. So how many fractions of these do I have? I have 5 of them. So I'm going to just write this as 2 over 3 to the power of 5. Okay, so this can lead to a new rule. Look at the exponents. In the first one, I have 4 and 5. In my simplified form, I have 9. Well, it turns out I can just add the 4 and add the 5 and I get 9. Is this rule true for all other powers that you multiply? Well, let's see. I have here for the base of 2, I have 3. For the base of 2, I have 2 as my exponent, so 3 plus 2 gives me 5. What about the other exponents? I have an exponent of 5 here and I have an exponent of 3 here, so 5 plus 3 is equal to 8. So far, so good. And then the fractions down here, I have 2 and 3 as my exponents. When I add 2 and 3 together, I get 5. So it turns out the rule is when I multiply powers with the same bases, write the base and then add the exponents. So for this one, my base is here, so I have here negative 2. And all I have to do is add the exponents. 2 plus 5 makes 7. So let's try out a few of them here. So try these out to make sure you understand. So that's so here I have 2 powers with the same base. The base is 7, so you just rewrite a single base, 7, and then you add the exponents, 2 plus 3, which is 5. I have 2 to the power of 4 times 2 to the power of 6, so my base is 2. Add the exponents, 4 plus 6 is 10. Here I have a base of negative 5. Add the exponents, 13 plus 12 is 25. Here I have 3 of them being multiplied. As long as the base is the same, you can still follow the rule. 6 is my base, add the exponents. 3 plus 4 plus 2 is 9. Okay, let's look at a different law, division exponent law, dividing powers with the same base. Okay, so the product of powers, 10 to the power of 6 divided by 10 to the power of 3. So what does this look like if I expand it? So I'm going to have 10 times 10 times 10 times 10 times 10 times 10. So this is 6 tens here, so it represents the 10 to the power of 6. Now I'm going to divide, which means I need to put a division line in there. I'll put a division line in there like that. And on the bottom, I'm going to write 10 to the power of 3 in expanded form. So 10 times 10 times 10. Now, because they're all being multiplied, I can make some cancellations. So I can make some cancellations. So let's cancel 1 10 from here. It's with 1 in the bottom, another 10 from the top and the bottom, and another 10 from the top and the bottom. What am I left with? I'm left with 10 times 10 times 10. So 3 of them. So in simplified form, I just write the base of 10. And because I have 3 of them, my exponent will be 3. Okay, let's try the next one. 6 to the power of 8. So I'm going to have 6 times 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 6. Just make sure that I have 8 of them here. So I have 1, 2, 3, 4, 5, 6, 7, 8, which is good. And then I'm just going to divide by like a division line there. Okay, and I'm just going to move that line a little bit down. What happened there? Okay. Oh, I went all the way down here. Let's bring it back up. Right there. Oh, that didn't work. Do I have to delete it and remake it? No, let's try that. Okay, there you go. That worked. Now, so I have 6 to the power divided by 6 to the power 4. So on the bottom, I'm going to have 4 of those 6's there. So 6 times 6 times 6 times 6. Then you can just start canceling out. It's one from the top, one from the bottom, one from the top, one from the bottom, one from the top, one from the bottom, one from the top, and one from the bottom. And I'm left with 1, 2, 3, 4. So I'm going to write my simplified form, 6 to the power of 4. Okay, let's try the next one, 2 to the power of 5 divided by 2 to the power of 5. Well, this one turns out to be a lot simpler. I write how 5 2's up in the top. And I'm going to just divide by, again, another set of 5 2's on the bottom. And you'll notice that it becomes really simple. I can cancel everything. Essentially, this just becomes 1 over 1, which is, or you can just say 1. So again, if you just, even with powers, if you have the same power on the top and the bottom, they cancel each other out and give you 1. Okay, so in simplified form, this is 1. But let's look at the exponents of the others. So, you have 6 and 3, and my final form is 3. It turns out if I subtract this exponent with the one on the bottom, 3, 6 minus 3 gives me 3. Let's check if this is true for the others. So, 8 minus 4 gives me 4, and 5 minus 5 gives me 0. Oh, so I should have written this, so 2 to the power of 0. Any number raised to the power of 0 is equal to 1, and that's why I have 1 down here. Okay, so it turns out when dividing powers with the same bases, you write the base and then subtract the exponents. So 2 to the power 7 divided by 2 to the power 3. All I have to do is write the base just once, subtract the exponents, 7 minus 3, like so, and then I can say that this is 2 to the power of 4. Okay, let's try these out here. So 2 to the power of 10 divided by 2 to the power of 4. Well, I'll just write down the base 2 and then subtract 10 minus 4, which is 6. Negative 4 to the power of 12 divided by negative 4 to the power of 10. Write your base of negative 4, put it in brackets, subtract the exponents, 12 minus 10. That's 2. 6 to the power of 7 divided by 6 to the power of 6. Write down your base once, subtract the exponents. 7 minus 6 is equal to 1, and that's 6. So I can say just 6. If it's anything raised to the power of 1, you don't need to write it like this. Just simplify it to just this base itself, 6. And bases could be decimals too, so 1.5 is your base. I'm going to write 1.5. Subtract the exponents, 3 minus 1, which would be 2. Okay, so that's our second law. Here's our third law, power of a power exponent law. So you have 10 to the power of 6, and then the whole thing is raised again to the power of 3. How might that look? Well, that would look something like this. I would just say 10 to the power of 6 times 10 to the power of 6 times 10 to the power of 6, 3 times, right? So if you remember from the first part, if you have powers that are being multiplied with each other, they have the same base. So here you have the same base, 10, 10, and 10. All you have to do is add their exponents. So 6 plus 6 plus 6. So in simplified form, I have 10 to the power of 18. 6 plus 6 is 12, plus another 6 is 18. Okay. And the next one, 10 to the power of 7 to the power of 2. So 10 to the power of 7 times 10 to the power of 7. Two powers being multiplied, and they have the same base. The rule is to add their exponents. So you write the base once, and then you add their exponents. 7 plus 7 is 14. Now it turns out, if you look carefully enough, 6. What's the relationship between 6 and 3 with 18? Well, if I do 6 times 3, I get 18. If I do 7 times 2, I get 14. So it turns out the rule is when a power is raised to an exponent, write the base and then multiply the exponents. Okay, so if you see, there's a little typo here, this shouldn't be here. Okay, so here's my examples. negative 2 to the power of 3 raised to another exponent of 2. So what you have to do is write the base, negative 2, put it in brackets, and then multiply the exponents. You're going to do 3 times 2, which is 6. So negative 2 to the power of 6. Okay, next one, a little bit more complicated. We have multiplication and division. So we're going to combine a couple of rules here. So if we combine the multiplication rule, we have to add their exponents if you have the same base. So I'm going to have 3 to the power of 4 plus 7 on the top over 3 to the power of 5 on the bottom. So 4 plus 7 is 11, so 3 to the power 11 over 3 to the power 5. And now I have a situation where I'm dividing two powers with the same base. So I have to subtract the exponents 11 minus 5. So up here I'm going to write 3 to the power of 11 minus 5. So write it as a single base and subtract the exponents. And that's going to be 3 to the power of 6.